Top H0 moins 1 minute.
So the DDO has called out the -1 minute. Here we go. We're getting into the final ignition sequence. Very close.
Now, describe the ignition sequence for us. What do we watch for?
Well, this evening we're not flying in Ariane 5 ECA but an ES, so we won't see the retraction of the cryogenic arms because they're not used. But what we will see will be the ignitions of the Vulcan 2 hydrogen cooling gas igniters at around -5 seconds. That's at the base of the thruster of the Vulcan 2.
Let me just stop you because you mentioned the cryo arms. Those are those yellow bars there that are folded that you can see right in the middle of the screen.
Exactly.
Normally they're feeding the upper stage. Tonight they're not because we're not using that version.
Then a zero ignition of the Vulcan 2 followed by verifications and liftoff with ignition of the SOBs.
Attention pour le décollage. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage Vulcain. Allumage confirmé. Top, allumage EAP, décollage. Tous les paramètres à bord sont nominaux.
Well, we lost her to the low clouds early, but in a blaze of light. There she is, coming back out of the clouds. Roaring off the pad. The DDO says everything is normal, propulsion and trajectory. In a blaze of light and a trail of gold as Ariane 5 reaches into the skies above French Guiana on her way to deliver ATV-3, which will make her way to the International Space Station next week.
We've lost her through the clouds. So the launch vehicle first clears the pad in a vertical rise. And you can start hearing the noise. And the launch vehicle has just passed Mach 1. It's past the speed of sound. 6 kilometers in altitude, 317 meters per second.
773 tons at liftoff. She's burning 5 tons of fuel every second, 2.5 tons in each booster. Those are the big flames on either side. And the EPC, the core stage, in the center is burning another 300 kilos per second. Ariane, following the program in the onboard computer, which gives all the orders, including stage separation, which we will soon see, because the boosters and the first stage are burning now. The boosters will burn another maybe 20 seconds and then get the order from the onboard computer.
In all, they will burn for around 2 minutes, and they will deliver 90% of the thrust at liftoff.
Boosters burning their 240 tons in just over 2 minutes. You can see the 3 points of light there, the 2 on either side. If they come back, it looks like we lost her to the clouds again. 2 on either side are the boosters. Luca, on the left, on the upper left of the screen, there's a cursor, and on the bottom left, A and V.
That's right. A, the altitude. We are at 63 kilometers already, 2 minutes and 20 seconds, and we are at 67 kilometers from Earth.
Séparation des EAP.
And the DDO just called out the successful extinction and separation of the boosters. You see what that looks like? There's one on the other side out of camera range. Dropped right on time and on target. Before the boosters are empty, their push diminishes, and this is what the onboard computer senses, a drop in acceleration, and then it separates them. Separation occurs 1 second after the onboard computer has detected this speed loss. Did you mention the altitude and the speed?
Right, so V, the speed, as you can see, 2.24 kilometers per second, not per hour. And if we look at the curve is a projection of where it should be, and the dot is the actual position of the launch vehicle. So as long as the dot remains on the curve, everything is going very well.
So it's real time superimposed on optimal. Excellent. A real trajectory is superimposed on the optimal provision. There's the mock-up of the ISS, the space station, here in the hall, which is sitting next to the mock-up of the ATV. We'll have more on that in a moment. We've had signal picked up by our first downrange tracking station. That's in a boat in the Atlantic.
We use 5 ground range tracking stations for this flight. We need them to recuperate the launch vehicle data during the flight, which is some of part verified in real time to see that the flight's going well, and the other is verified after the launch in greater detail to see that everything is also going well. 8 minutes and 12 seconds into flight.
Tous les paramètres à bord sont normaux.
Everything is going on well, and we're getting close to the second event, the extinction of the EPC with its separation, and then the EPS stage. So the EPC, 30 meters long, 4.5 meters
Les
wide.
paramètres de propulsion et de pilotage à bord sont normaux. Le vol est calme.
Everything okay, he's saying.
And a total mass of 278 tons, with only 14 tons of dry mass, and the rest is all propellant, liquid oxygen and liquid hydrogen. A thrust at liftoff of 136 tons, and a flight time of some 8 minutes and more. So we're getting close by.
Which is coming to an end. You'll hear the DDO call out the extinction of this core stage. We're waiting for
Extinction de
confirmation of
l'EPC
that.
sur commande de guidage.
And there it is.
There it is. So the EPC stops once
Séparation de l'étage principal cryotechnique, l'EPC.
separation of the stage, as we can see.
You can see how that happens there. There's 3 commands given in the space of about 12 seconds. The extinction of the lower
Première
stage,
allumage de l'EPS.
the separation of the lower stage, which you can see, and then
Tous
finally
les paramètres à bord sont
the
nominaux.
ignition of the upper stage. Our speed, as you can see, 7 kilometers per second. Our altitude, 100 and coming up to 140 kilometers.
And now the EPS is starting to burn. We'll have 3 burns for the EPS. It's a small stowable propellant stage, and it will give us the 2 burns, the 2 burns necessary for the mission, and a 3rd burn to deorbit it at the end of the mission.
Would you say that's the role of the EPS, the upper stage? Does that sum it up, or is there more?
The EPS is interesting because it's a reignitable. We have to put the ATV on a circular orbit, and this is what we can do with an EPS. But you can only do that if you have a reignitable stage, which is so. So the first burn will take around 8 minutes and 11 seconds,
Les paramètres de propulsion et de pilotage à bord sont normaux. Le vol est calme.
and everything is going well. Then the second burn, after a very long ballistic phase, will give the necessary impulse and speed to make a circular orbit, and after that we'll have the separation.
During the film there, we were picked up by our second downrange tracking station. You can see it there. It's in the Azores in the North Atlantic. Santa Maria, it's called. You wanted to say a word about the different propulsion systems on Ariane 5 because we have solid propulsion in the boosters and cryogenic propulsion in the upper stages.
The main core stage, and then we have a stowable in the upper stage. On this version, we have 3 different propulsion systems. They're solid rocket boosters, the AP. They use 240 tons of powder. They provide 90% of the thrust at liftoff. A total liftoff thrust of 600 tons. It allows us to lift this massive launch vehicle and takes it out of the dense part of the atmosphere. Then the EPC takes over. Very efficient cryopropulsion, a thrust of 136 tons. Burns for some 534 seconds, and it positions the launch vehicle in an
Les
intermediate
paramètres de
orbit.
propulsion et de pilotage à bord sont normaux. Le vol est calme.
Just before the EPS took over. The EPS, small, stowable propellant stage, 9.2 tons of thrust, but with a reignitable capacity. So this will allow us to position the ATV exactly where we need to position it on a circular orbit that it requires just before separation.
You mentioned the cryogenic stage was efficient. Does that mean it's more efficient than the solid propellant?
The use of
Première extinction de l'EPS et début de la phase balistique qui va durer un peu plus de 42 minutes.
Before you answer, the extinction of the first burn in the upper stage has just happened. You can see the engine shut off. So we're coasting now. Before we talk about coasting, answer my question about efficiency in propulsion systems.
the cryopropulsion is much more efficient. If you use liquid oxygen, liquid hydrogen, you'll have a much more efficient motor and engine. So that's the reason. However, it's more difficult to reignite. So an EPS is easier to reignite, and that's exactly what we needed it for.
Okay, so we are in a what they call a ballistics phase. Also, I think a barbecue phase, which you can see because the ATV is turning on herself. Why is it turning?
We're going to have a very long coast phase, and some parts of the spacecraft, so the upper composite, which remains of it, it may be contact with the sun. So to equalize the thermal loads, you put the upper composite in a very small roll mode, what we call barbecue, so that you don't have a same point always aiming at the sun and another point always in the shade, which would create a disequilibrium in the thermal loads.
All right, so the ATV spinning up, you can see what's left of the composite of the 773 tons. You have the 20 tons of the ATV and the various adapters and the rest. 26 tons, maybe.
On the very bottom ring, what we see there, you see the EPS, and you see what remains, or the other ring is the VB, the vehicle equipment bay, where all the, let's say, the electronics of the launch vehicle is situated.
In the